Today we're discussing how to solve a simple system of equations using a method called substitution. So in our previous lesson, we learned how to solve a system of equations by using the graphing method. Now the graphing method works wonderful only if the coordinates of the solution are small integers. Now, when you get into your rational numbers or larger integers, it's going to be more difficult to find the solution by graphing. So we have other methods that we can use if the solutions contain large integers or fractions and rational numbers. So the method that we're going to talk about today is the substitution method. And we're actually going to start with using simple systems, and then in 7.3 we'll talk about more complex systems that also use the substitution method. So the substitution method is going to find a single variable equation by replacing one of the variables with an equivalent expression. So once that equation is solved, you can use the result and substitute it into one of the equations to find the value of the other variable. So let's take a look at an example. In example 1, we have x plus y equals 5 and y equals negative 3x plus 7. So what we want to do is we want to take the expression that is equal to y here and substitute it into the other equation, and we're going to substitute the expression that is equal to y and substitute it for y in the other equation. So instead of saying x plus y, we're not going to write y, we're going to write the expression that is equal to y, which is negative 3x plus 7. So here we substituted negative 3x plus 7 for y, and then we still have equals 5. Well, now we have an equation where there's only one variable. So now we can solve for that variable x. So we'll start with distributing across these parentheses, and then we'll have x plus negative 3x plus 7, and then x plus negative 3x is negative 2x plus 7 equals 5. And then we'll subtract 7 from both sides, and we'll get negative 2x equals negative 2. And then we'll end up with x equals 1. And now that we know that x equals 1, we can use that information and substitute that in to one of our equations and to solve for our other variable, y. So remember, since we know that x equals 1, we just did that. Now we know that y is equal to negative 3x plus 7. So instead of saying negative 3 times x, since we know that x equals 1, we can use substitution to replace x with 1. So now we have negative 3 times 1 plus 7, which means y is equal to 4. Now remember, our solution to a system is always going to be an ordered pair. So if you had just stopped by telling me what x is equal to and what y is equal to, you're actually not correct. You have to write it as an ordered pair. So our solution and our answer to this problem is the ordered pair 1, 4, because x was equal to 1 and y was equal to 4. So in our next example, we have x plus y equals negative 4 and x minus y equals 10. So notice in this one, we don't have a variable solve for. However, we can easily pick an equation and solve for a variable. So let's do this one. So instead of saying x plus y equals negative 4, I want x to be by itself. So I'm going to subtract y from both sides, and then I have x equals negative y minus 4. Now I have an expression that is equal to x, which I can substitute into the other equation. So instead of writing x, I can write negative y minus 4 into the other equation. So instead of writing x, I write minus y, or negative y, minus 4, and then I finish out the equation. So minus y equals 10. Okay, so now I have an equation where I just have one variable, which is great because I can solve for that variable. We'll start with combining like terms. Minus y, that's negative 2y, minus 4 equals 10. I'll add 4 to both sides, and I have negative 2y equals 14. Divide both sides by negative 2, and I have y equals negative 7. Now that I know what y is, I can go back and solve for x. Since I know that y equals negative 7, I can use the information that x is equal to negative y minus 4, and I can substitute negative 7 for y in the equation. So instead of saying negative y minus 4, I can say negative 7 minus 4. So that means that negative 7 becomes just 7, minus 4 is 3. So that means x equals 3. Not quite done. I do have to write my solution as an ordered pair. So x was 3 and y was negative 7. So my solution is the ordered pair 3, negative 7. All right, so here are the steps to solving a system by substitution. Step 1, solve either equation for either variable. This is where you get to choose. You choose the easiest variable to solve for. Sometimes you already have an equation that has a variable solved for, and then you don't even have to do anything for step 1 other than choose it. Step 2, substitute the solution into the other equation to obtain an equation that just has one variable. And once you have that new equation that only has one variable, then you can solve. Step 3, use the value of the known variable, which you just solved for in step 2, to solve for the other variable. Then step 4, you write the solution as an ordered pair. And then step 5, you want to check your solution by substituting into each equation and checking it to make sure that it works. So I want you to go ahead and take a look at example 3 in your textbook. So example 3 is a little bit more complex. So you'll notice that the easiest variable to solve for in example 3 is the x in the first equation. And so we end up with x equals 4y. And so then we can substitute 4y for x into our other equation, and we get 3 times 4y instead of x plus 2y equals 8. And then we can solve for y. So we get 12y plus 2y equals 8, which means 14y equals 8, which means y is equal to 8 over 14, which is reduces to 4 over 7. And then we can substitute 4 over 7 for y into our other equation, x equals 4y, which means that x is equal to 16 over 7. Okay, so in example 4, if you'll take a look in your textbook, this is a problem where you're trying to solve the length and the width, and you're given the perimeter. So the first thing you need to do is you need to write 2 equations that involve length and width. We're going to use L for length and W for width. So we are told the length is 6 feet longer than the width, which means that L, the length, is W plus 6 because it's 6 feet longer than whatever the width is. So W plus 6. So that's our first equation. We can use the perimeter formula to help write the other equation. So remember, perimeter of a rectangle is equal to 2 times the length plus 2 times the width. We know that the total perimeter is 84, which means that 2L plus 2W is equal to 84. And remember that we know that length is equal to W plus 6, so we can use substitution to replace L with W plus 6. So instead of saying 2L, we can write 2 times W plus 6 plus 2W equals 84. Now we have an equation with just one variable, which means we can solve for that variable. So here we are. We're going to distribute that 2. So we get 2W plus 12. And then we'll go ahead and bring down the other information, plus 2W equals 84. And then we'll combine like terms. So 2W plus 2W gives us 4W. Bring down the other information, plus 12 equals 84. This is a two-step equation. We'll begin by subtracting 12 from both sides. We'll get 4W equals 72. Divide both sides by 4, and W is equal to 18. So now we know what the width is. And since we know what the width is, remember the length was the width, well, 6 more than the width. So that means that the length is 18, because we can substitute 18 for W, plus 6, which means that the length is equal to 24. So now we know the width is 18 feet and length is 24 feet. All right, you are now ready to try some problems on your own.